These physics problems involve determining the time period of oscillation for a body attached to a spring system, given the mass of the block that extends the spring and subsequently replaced by another body. Along with the displacement caused by the initial block, the problems requires calculating the spring constant and then using it to find the time period of the oscillation for the second body. Let's assume we're given this kind of problems, which says a 4 kg block extends a spring by 16 cm from its unstretched position. The block is then removed and a 0.5 kg body is then hung from the same spring. If the spring is then stretched and released, what is the time period of oscillation? Since there is going to be to and fro manner in this problem. In this case, the first diagram, which is here by my left hand side, this is the position that is at equilibrium position of unstretched. The second diagram, which is 16 cm, this is when the spring is being stretched by 16 cm from the equilibrium, while the third diagram actually describe or indicate the release, that is the oscillation moving up and down to and fro manner. So how can we solve this problem? So first thing we need to do in order to solve this problem is to find the time period of the oscillation, the 0.5 kilogram body. First thing we need to do is to determine the spring constant using the Hooke's law. According to the Hooke's law, our F is simply going to be negative kx. In this problem, F is the force exerted by the spring, k is the spring constant, and x is the displacement from the equilibrium position. Equilibrium position, that is x, is simply going to be 0. Given that 4 kg block extends the spring by 16 cm. 16 cm, if we convert that into meter, is simply going to be 0.16 meter. We can find our k, which is the spring constant. How can we find our k? First thing you need to do is to make what? The k to be the subject of the formula. In this case, we are going to make this k is negative. When we move it to the left hand side, it's simply going to be positive. Therefore, we're going to have k is going to be our F divided by x, which means our k spring constant is what? Is the force exerted by the spring divided by x, which is the displacement from the equilibrium position. So, the force exerted by the 4 kg is what? F is simply going to be mg, where m is our mass, which is 4 kg, and g is our center of gravity, which is 9.8 meters per second. Therefore, our force is going to be 4.0 kilogram. We're going to multiply it by 9.8 in meter per second square. And our force, if you multiply everything here, is simply going to be 39.2 Newton. Let's put it this way. Let's say our force is what? 39.2 unit of force is what? Newton. Now that we have found our force, next thing we need to do is to find the spring constant. And this is the formula for us to find our spring constant, which is k. The spring constant is going to be k, which is our force, divided by x, which is the displacement. Our k is simply going to be, our F is 39.2, is going to be 39.2 in Newton divided by x, which is what? Remember, our x is in centimeter, which is 16. We need to convert that into meter, which is going to be 0.16 in meter. If we divide that, our spring constant, which is k, is simply going to be 245 Newton per meter. Therefore, our force is 39.2 Newton. Our k is 245 Newton per meter. So now for the 0.5 kg body, the equation for the time period of oscillation is simply going to be T is going to be 2 pi omega. We have found our spring constant. Next thing we need to find is the period for oscillation, which is given by T is simply going to be 2 pi omega. Omega is the same way as writing the square root of m divided by k. In this case, you can choose to put it differently by saying our T is simply going to be 2 pi into square root of m all over k. Remember, our m is the mass, which is what, 0.5 for the second problem, which is 0.5 kilogram, and our k is the spring constant, which is 245. Therefore, our time period is simply going to be 2 pi into the square root of mass, which is 0.5 kilogram, divided by 245, also in what, Newton per meter. Alright, which is the same way as saying our time period is what, 2 pi into the square root of 0.5 divided by 245. If you punch on your calculator 0.5 divided by 245, this is the same thing as 0.00204. Remember, it's actually in square root. It's going to be 0.00204. We're going to bring back our 2 pi, and time period is still going to be there. Next thing you need to do is to find the square root of 0.00204, and this is simply going to be 0.0452. Then you multiply that by what? 2 pi. And this is going to be your time period. If you multiply everything by 2 pi, this is simply going to be 0.284 in second. So, the time period for oscillation for 0.5 kilogram is approximately 0.284 seconds. So this is it for this problem. Thank you for watching. See you next time. Don't forget to subscribe.